Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at the alkenes and its reactions. Alkenes is actually another type of hydrocarbon. In the last video we have looked at the different type of hydrocarbons. So if from the crude oil you actually extract hydrocarbons. Hydrocarbons are the compounds made by carbon and hydrogen, and you have two types. Number one, you have alkanes, and then number two, alkenes. Alkanes examples we have done, if you remember, we have done methane, then we have ethane, and then we have propane and butane and so on. In alkenes, which is another type of hydrocarbon present in the crude oil, it is actually start with ethene, the smallest one, then you have propene, and then you have butene. Now if you remember, I have actually told you that these hydrocarbons, some of them they are saturated. So alkanes are saturated because they have only carbon to carbon single bond, and alkenes are actually unsaturated because they have carbon to carbon double bond. It can be one or two. Now alkenes, I can write it down ethene, before it was ethane. That's why this is called an alkene. Ethene, and then you have propene, and then you have butene. So we're just going to do these three. These are unsaturated. If you remember, we have done alkane, and I told you that each carbon atom will have one single bond between carbon to carbon, and it has three hydrogens like that. And I told you this can be predicted from this formula. If you have two carbon atoms, you just put it to 2 there, and then you replace n by 2 again, plus 2, so you will get C2H6, and that's why you draw like that. That's ethane. But now we have ethene, so we will look at how actually we're going to predict that, how is it different from ethane. Now alkenes, they have a general formula of CnH2n plus 2. If you remember, alkanes have a general formula CnH2n plus 2. But here alkenes have the formula CnH2n only. So there is no plus 2 there. It is not there. That means whatever the number of carbon atoms you have, it is doubled when you are dealing with the hydrogen. So ethene obviously is 3 carbon atoms. This is 2, 3 and 4. Now I'm going to put this 2 in here, and I can predict the molecular formula of ethene. So C2H2 into 2, and that will make C2H4, double number of hydrogens as compared to carbon. Then I have propene, so C3H2 into 3, because 3 will be replaced instead of N, so that will be C3H6. And then you have butene, C4H2 into 4, and that C4H8. You can see that each of them is differing from the other by CH2 and CH2. Now because they are actually having the same functional group or same group which is differing from each other by the neighboring hydrocarbon, this is called actually a homologous series. So alkenes family also has got a homologous series as well. Now we're going to look at how we're going to actually display the formula. So the display formula for alkenes are, you have 2 carbon atoms and 4 hydrogens. So my advice is still going to be the same, that can you please actually draw the carbon first. C2, so you're going to put C2. Now I told you already that ethene is actually a compound where you have carbon, they are unsaturated and they have carbon to carbon double bond. So you should have at least one double bond in the whole chain. Because there are only 2 carbon atoms, so I will put the double bond between them. Now carbon can have 4 bonds, so each of the carbon already has got 2 bonds each. That means both of them can have more another 2 bonds. So those 2 bonds is gonna be with the hydrogen. Now automatically you will see the formula is C2H4. C2H4. That means alkenes have 2 less hydrogen as compared to alkanes. If I draw propene and butene, you can actually pause the video and you can actually do it yourself. Oh, I can do that for you. C3 I will draw is like this: 1, 2, 3, 3 carbon atoms. And rather putting these 6 there first, the first job is you have to put a double bond. It is your choice whether you want to put double bond there or there. It doesn't really matter. If you put double bond there, this carbon atom has got 2 bonds already, so it can have 2 more bonds which it is going to make with hydrogen. This carbon atom has got 2 there and then 1 there. It has already got 3 bonds, so it requires only 1 more bond which will be going on top of it with the hydrogen. This carbon atom has got only 1 bond and it can have maximum of 4 bonds because it belongs to 4th group. So that will also have 3 bonds with 3 hydrogens. Automatically the number of hydrogens will become equal to the number 6. And you come to butene, 1, 2, 3, 4. You can put that double bond because it should have at least 1 double bond. You can put it there, there is your choice. There is no restriction. You put double bond there and now you will start filling the hydrogens. Don't worry about that. It will automatically become equal to 8. So this carbon has 1 bond, so it can have 3 more because each carbon should have 4 bonds. This carbon already have 3 bonds, so it will only have 1 hydrogen. This carbon has 2 and 3, it will have 1 as well. This carbon has only 1 bond, so it will have 3 hydrogen atoms around it. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, you got 8 hydrogen atoms around carbon. Automatically it will be 8. Now if you want to make some notes, you can make the notes or take a screenshot. I'm going to look at the reactions now, that how alkenes react with the other compounds. We're going to do 3 reactions and we will quickly look at how alkenes behave with the hydrogen and halogens or with the water. Now alkenes, let's just take an example of propene. If we do propene, that's how it looks like. So that means it has got hydrogen around it. I'm going to react it with hydrogen. Here's the point. Alkenes actually react with the hydrogen or any other compound, and this double bond will be actually converted into single bond. That means the double bond will be broken and this will be added to each carbon atom. Now you just consider that 2 people are actually doing a business, and you get some sort of benefit like £100,000 you get it. Each of them who are doing the business together will get half of it. So there are 2 hydrogens. So 1 hydrogen will go to this carbon and other hydrogen will go to that carbon atom. So you will write it down like this again, but this time you do not put the double bond there. It's broken. You have 3 hydrogens there as it is. I'm gonna write down all the hydrogens which exist already, and then I'm going to put the rest of the hydrogen. This hydrogen which will be added as like this. So 2 hydrogens, so H2 means 2 hydrogen. So basically it was like this. It was broken like this way, and it will be added to each carbon atom. But main point is there is no double bond left. Single bond is broken. The second is I can just do one more example where you actually do hydrogenation. This process is called hydrogenation, but you do not need any catalyst for this because hydrogen can easily be added to ethene. Once you got that, you break this bond and then you will add that. So each carbon atom will get one hydrogen. Second is when alkenes reaction with halogens. Now halogens are actually chlorine, bromine, iodine. All of them are diatomic molecules. When alkenes react with halogens, so we're going to take an example of propene again, and let's just react it with bromine. Now again, bromine Br2 means 2Br, so one atom will go there and one atom will be added to this, and you will draw like that, no double bond this time, and you will put hydrogen, 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 whatever is present there, you draw that exactly as it is. The bromine will be added as Br and Br. Now once it's done, you can have a look that bromine is added, hydrogen is added. That means alkenes undergo addition reaction. They haven't substitute anybody to take their to make a place. They have actually been added and no extra product is actually made. That's why it is called addition reaction. So if they ask you, you can tell them alkenes actually undergo addition reaction. Now another reaction is, for example, C2H4, it is actually ethene. Ethene, when it reacts with oxygen, is just like when you burn methane gas at home. Ethene is also a gas. When you burn them, all the hydrocarbons, when you burn them, doesn't matter what they are, methane, ethane, propane, butane, octane, whatever, they all produce the same thing, carbon dioxide and water. So you will produce carbon dioxide and water. The examiner can actually ask you in exam, can you write down a balance equation to balance this, how they actually reacted. Now ethene is reacting with this. You have two carbon atoms, one carbon atom there, you put two there to make sure you balance it. You have four hydrogens, you have two hydrogens, you put two there, and that will make four hydrogens. Now you have total of two hydrogens, and here you have 2 plus 2, because that 2 goes for the oxygen as well. So total of 4 oxygen there, so you put 2 there, and that is a balance equation for the combustion. Because ethene has reacted with oxygen, so that is called combustion reaction. Now here's the point. When you have reacted with bromine and hydrogen, they have actually added, but they have added into the double bond. But in this case, it's not going to happen. Oxygen is not going to be added separately. So that's why you cannot actually draw that same kind of formula. Now I'm just going to change one thing on the top. Reaction with the steam. So I'm just going to remove this. If you want to make some notes, you can make. Otherwise, I'm going to remove it. Now I'm just going to remove this bit because you don't need that bit. And we can use that space to state the reaction with steam. So alkenes reaction with steam. Now you all know steam is actually water, right? Because steam is actually water, so water has got formula of H2O. Water can be written like that, HOH. So it will actually have two parts, hydrogen and hydroxyl group, OH group. So now because you know now the water has got two groups, what you're gonna do, you can actually have an alkenes called butene. So you can actually have butene like that, which is C4H8. You're going to react with water, which is HOH, which is steam. Hydrogen will be added to one carbon and hydroxyl group will be added to the other carbon atom. Hydrogen and OH. I haven't drawn the other hydrogens around it, just to make sure that you understand that it has added hydrogen and hydroxyl group. But in exam, you have to draw all of them. Now, here's the point for the extension question for the triple science groups. For the higher tier, this hydroxyl group which you have added on this carbon atom, it could have been added to here, and this hydrogen could have been added there. So there are two different types of products you can have. So if they ask you draw the two different products, you will be surprised. No, you shouldn't be surprised, because this hydroxyl group can be added there or there. So that's why you will have a mixture of different products. It will have the same molecular formula, but it will have a different position of hydroxyl group on this carbon chain. So see, everything is the same. The molecular formula for this is C4H7 1 2 3 4 5 6 7 8 9 10 5 6 7 8 9 10. Yeah, so 10, and then you put O there, and this is also C4H10O. So that's how it looks like. Molecular formula is same, but the position of OH group is actually different. So you can, if they ask you one mark question, you can draw that. All right. So you have a reaction with hydrogen. You can have a reaction with the halogens. It can be Br2, I2, Cl2. Every time the result is going to be same. You can have a combustion reaction where they produce carbon dioxide and water. The only thing you have to do is actually you just sort out the balancing the equation. The last bit is actually the reaction with the steam, which means water, HOH. You break the water HOH into two parts. Hydroxyl group can be added in both, so you can have two products. All right. Thank you very much.